Good evening, everyone. I'm Siddhi, and I will be presenting recursive functions and Fibonacci. When a function calls itself, the situation is known as a recursion. For a recursive function to work, it must have a termination condition to prevent infinite loop. Fibonacci numbers are a sequence of integers. They are built using a very simple rule. The first element of the sequence must be equal to 0, and the second number of the sequence must be equal to 1. To design the solution, we must follow the following steps. First, identifying the base case. Second, defining a recursive relation. Third, breaking the problem into smaller subproblems. And fourth, combining result to get final answer. Here is Python implementation. If we use an if-elif structure for the base case to return 0 or 1 immediately for the recursive step, the function call itself twice. This directly implies the mathematical formula into a Python script. Looking at the recursion tree for F5, we see a major issue, overlapping subproblems. Notice how F3 and F2 are calculated multiple times. This is this is why simple recursion can be inefficient as the tree. Our analysis shows that while the output is correct, but the process of reaching it involves too much repeated work. For complex problem solving, we must address these limitations. Recursion has high complexity but is slow for large value of n. We can optimize this by using iteration as it uses loops, avoid repetition, and has time complexity. Here we will be comparing the two. First, recursion is simple but slow and it has high memory. On the other hand, iteration is complex but it is very fast and it has low memory. We must look at professional ethics. First, the work is original and understandable. Second, no plagiarism. Third, the concept explained in its own words. And now the conclusion. Recursion is powerful. Recursion simplifies the problems, but iteration improves efficiency. Thank you.